So I'm just going to. Last time I realized that everybody was interested in learning about JASP. Okay, so today I'm just going to give you a 10-15 minute introduction to JASP, and then we'll do ANOVA on JASP itself. Okay, so I'm going to share my screen and I'm going to show you the JASP software. Okay. Okay, can you see my screen?
Yes, ma'am.
Yeah, yeah.
Okay, so I did a little research on JASP and stuff. So research JASP is actually made on the R platform. It's completely free and it's very intuitive. So I have been, since morning, I have been trying out JASP and I have really liked it. So therefore I said that okay, let's do some of this analysis. So all of you have downloaded JASP. Would you like to just open it?
Yeah.
Just open. Everybody, can you open JASP, please? Everybody is done.
Take it.
No issues. Take your time. And then I'll kind of show you where you can learn a little bit more. So everybody is kind of, it's very intuitive. You can do your analysis. You can copy paste your analysis. You can write it in your research papers, and you don't have to pay a penny. No coding required. No learning anything which is you don't have to learn R. Okay, it's very intuitive, very simple. Okay, everybody is open.
Yeah, I open.
Okay. Okay. And just in case the light conks off, okay, I don't have mobile internet. So therefore, it will take some time for my Wi-Fi to switch on when the light goes off. So just in case something like that happens, so you know, um, just bear with me. Okay. Shall I start?
Yeah, yeah.
Okay. So if you look at this particular screen, okay, you can see that I have something called descriptives. I can do t-tests. I can do ANOVA. I can do mixed models. I can do regression. I can do frequencies. I can do factor analysis, right? Now, there is something called, so there is on the right hand side, when you click on this plus, okay, you will find that there are many other things that you can do. Okay, so for the most part you don't need all of this, right? So I can unclick it. Okay, I don't need to click, but if you want to do this, you can pretty much do all of this. Okay, so you can add you know modules if you want. Okay, so you can actually do structural equation modeling. Okay, time series, visual modeling, right? So all of this you can do, and the best part is it has everything, and it's completely free. Okay, but these are some of the modules that are there. Okay, now this three lines that you see, right, if you click on them, okay, Okay, now this will give you something like, it will give you about something in terms of your about the software. So when everybody just click about, right, it will give you a version. Okay, it's always open source. Okay, and they'll keep making some kind of changes and all. So this version right now is July 13, 2023. Okay, so as and when, so they will allow you to kind of, update it as well. Okay, so this is basically the version. Okay, now the good part is out here, if you go to the open file. Okay, now this of course is showing me all the open files and stuff. Okay, whatever my recent files are on my computer. Okay, then there is something called an open science framework, which, you know um, which I am not a part of. I don't know any of you else are part of. Okay, then there is something which is a database, which is normally we don't need. Now there is something called a data library. Okay, now in a data library, if I click onto books. Okay, now it gives me this entire data sets are from these two books that you have. Okay, so if I click on them, okay, I will find all these data sets. Okay, which I can play around with. Okay, okay, then I have something called descriptive. Okay, now basically what they have done is that for each type of analysis they have given you some built-in files. Okay, now these are read only files. It will do the analysis, it will show you the analysis. Okay, but you can't edit the files. Okay, if you want to edit these files, these are locked files because they come with them, but you can pretty much open your own files. But it's a great way to learn. Okay, so I am just going to open one particular file. Okay, which I have never opened before. Okay, and this gives me a file out here. Okay, now this is the menu, which is basically the results menu, or you may call it. Okay, now what happens is that this is on this, when you open this data file, it has in your built-in data, it has some analysis that is already given to you. Okay, so for here, so just for me to learn something. Okay, so this was a file. Okay, now this is it gives you a description that this variable data set sleep provides a number of additional hours that 10 patients slept after having been administered two soporific drugs, sleeping pills. Okay, so this is variables increase of sleep in hours relative to a control drug. Okay, and type of a soporific drug. Okay, so these are the number of hours. Okay, now if I it's given me, these are the variables, right, and it is there. Okay, and if I look at the statistics. Okay, now when I go to statistics, it will show me, because they've already done the analysis, so they've shown me some analysis. Okay, so they've given me two of these groups. Okay, basically the two minimum. So it gives me the descriptive, it gives me box plots. Okay, I have options of, doing maximum dispersion. Okay, so it has already done all of this analysis for me. Okay, if I go to basic plots, if I click on this, it has this. Okay, if I click on tables, let's say if I click on tables and I say I want frequency tables. Okay, so then the moment you click on something, it will give me something out here. Okay, so right now that it doesn't give me anything. So let me just see if I can let me see if it's giving me something. Okay, so it's given me, it's actually done some business out here in terms of ID. Okay, these were the 8 variables. Okay, and it has given me some split. Okay, and so I don't know what the table looks like, but I have to go and see what the data set looks like. But it will pretty much give me give me stuff. Okay, so it has, if you go to the internet, if you go to YouTube, right, you will find a whole set of videos which will allow you to do some analysis. Okay, so right now, because I mean I'm interested in doing ANOVA, so I'm going to just stick to ANOVA. But you have things like t tests, okay, and you have independent samples t test, paired samples t test, one sample t test. This is all that stuff we've already done. Descriptive analysis, right? It will give you uh, quartiles, percentiles, median mode, standard deviation, right? Coefficient of variation, interquartile range, right? So all of this you can do. Okay, so I'm going to just try one variable. I'm going to just open one file. Okay, and I will go to my computer, and let's say I will go to final presentation, and let's say, okay, I'm going to go to heart rate. Okay, now this is a CSV file that I had. Okay, now this is the file that I have. Okay, and I'm looking at, this is gender, this is group, and this is heart rate. Okay, can everybody see this? Can everybody see this?
No.
No, ma'am.
Is my screen not being shared?
Yes, screen is visible, but it shows something on the right hand
One
side.
sec,
It is
let me
is
again share it.
We could see the descriptive
Okay,
statistics slides.
yeah. Can you see this?
Yes, ma'am.
Okay, so what I have done is I have gone to the file, I've opened, and I've gone to my computer, and I have picked up a file. Okay, now the only thing is that in JASP, okay, you cannot, it will not pick up Excel files. It will only pick CSV files, it will pick DAT files, and it will pick up SPSS files. Okay, so SPSS files it picks up, and CSV files it does pick up. It does not pick up Excel files. So in case you want JASP to pick up a file and read a file, you will have to save the file as CSV before it allows you to pick up. Okay, so right now what I went is I went to the computer, open. Okay, I went to my computer, I went to final my folder, and I had a file which is called heart rate. Okay, and this is a comma separated file. Okay, I opened it. Now this is basically read. It is imported my data from CSV. Now it is giving me these variables. Okay, now if I click on this, okay, I can change the labels. Okay, I can change the variables if I want to. If I had 1 and 2 out here, but right now it has already given me variables, so I don't need to do that. Okay, cross. Okay, it always also allows me to change the column type. If I click on this, right, whether it is an ordinal or a nominal, right? So this is obviously not so this is a nominal, so it will, I can change this. Even this is a nominal file. Okay, this on the other hand is a scale variable, so it gives me a notation of a scale variable. Okay, I can of course edit the data also if I want. Okay, now if I want to do descriptives, let me just click on descriptives and see what happens. Okay, so I have a descriptive. I want, let's say, because this is the only scale variable, let me, I can either drag this. Okay, or I can just double click this, it will come here. Okay, or what I can do
Ma'am,
is,
now the
yeah,
screen is again
we
not
cannot
showing.
say.
but I haven't changed the screen at all.
Yeah,
Can
you
you
have
see?
not seen. We can see the three groups, but where are you clicking that we are unable to see.
uh okay, let me just send you the CSV file. Okay, one sec. uh, Okay, everybody's got the file. Okay, has everybody opened JASP? You'll have to tell me in the chat. Huh? Okay, can I once again go? Okay, so when I click on the three dots, can everybody see my screen?
Yes,
Everybody can see my screen now?
yes, yes.
Okay, so when you click on these three dots, okay,
Mm,
these three lines, right? The first thing you
mm,
have to go is open, okay?
mm,
Then go to your computer, okay? And then you can browse and find wherever your files are kept. Click on the
mm,
file. Let's click on heart rate, okay?
mm,
Open, okay? You should see a file like this. Has everybody seen a file like this?
I got the columns arranged, the three columns arranged with heart rates,
Yeah.
groups, and
Gender,
gender.
group, and heart rate.
Yeah.
Whatever my screen is showing, it should show in yours.
It's not like this for me. The values are already added in the columns, and I can
Yeah, the
see.
value should be already there in the column because there was value already there,
Yeah,
right? The same values will be there. It will be there in yours also. All of you should be able to see my screen.
yeah, yeah.
Okay. Now, when I see this screen, now there is a icon which says descriptives.
Mm,
Okay. Can I just have to take my mouse button and just click on descriptives. Okay. So everybody click descriptives. Now you should get a box like this.
Really, I think your screen is not changing.
Okay. Can you see it now?
And we can see two boxes. One is
Yeah, that is
descriptive
exactly. You
classes,
see two boxes. One is gender,
and the
group, and
other one
heart
is
rate, and the
variable.
other is variables.
Yeah.
Okay. So this is the console of JASP. I'm just demonstrating the software. This is the console. Okay. So on the left hand side, when you see this gender,
Mm,
when I see this gender, can you see that? Can you see this
yeah.
gender, group, and heart rate?
Yes, yes.
Yes, ma'am.
Okay. So now if I drag heart rate to my variable sections, okay. Now please select heart rate and take it to the variable section. And just drag it to the variable section. Okay. Now what I'm going to do, you can see statistics out here. Can you see statistics out here? Right? So what I'm going to do out here is I am going to, when this arrow is there, I'm going to just click on this arrow. Okay. So when it says, when I click on the arrow, you will see some statistics out here. You will say, look at, there is an option of doing valid, missing, mean. Okay. Now, right now it is giving me, you can see on the right hand side on the result section. Okay. This is my result section. This is my result section. Can you see this?
Which one? Yeah.
On the right hand side,
Descriptive.
statistics, you can see, right? You can see that, right? This is this part. Okay. This is my descriptive statistics. Now you can see that I have valid, missing, mean, standard deviation, minimum, maximum, and it's telling me that I have got 800 observations. Okay,
Valid.
my mean is this. Okay, now I can also do something. I can click. Okay, I can click. Okay, I can click and I can select something like mode. Right now, the moment I do mode, you can see this mode has also come here.
Just not seen in your screen only.
You can see on the right hand side, now you can see a column which is in the same circle. Let me see, just let me show you this thing. See if I show you this, right, this here, you can see the mode.
No, there is no more there.
Yeah,
We
earlier
can
there
see
was no
valid.
mode. Now you can see 128. I had clicked out here. I had clicked to selected mode mode out here, right? If I want to go want to go to quartiles and percentiles, right? Now you notice, okay. Now you notice that I have now minimum, maximum, 25th percentile, 50th percentile, and 75th percentile. Now it is giving me these values. Now these are all descriptive statistics. Okay, so I can, if I use my mouse, I can actually copy this file. I can copy this table and put it in a Word file. Okay, if I do this calculation, I can just copy this file and I can do it in a LaTeX format also. If I want, I can add a note in my file also, right? And say, this is the descriptive statistics for heart rate. Right? I can do this also. Why don't you guys try it? Please try it and tell me you have tried it. Please do it. I'm just giving you because so that whatever we do, you can actually do things on your own.
So Vinti, we are unable to see your screen where you have written this is the descriptive statistics of Apple.
My screen is being shown out here. I mean, there's nothing else I can do. My screen is as wide as possible.
No, your screen still shows descriptive statistics with the valid, missing, mean, standard deviation, minimum, maximum. That's all what you can see.
Okay, let me
And there is
refresh.
no value.
Can you see it now?
No, ma'am. Like maybe if you can just share the entire screen instead of if you are
Mm.
doing window, maybe if you can share the, because whatever you are doing in
Okay,
the
okay, one
screen,
sec.
that is not working.
Okay, one sec. Share screen. Okay. Okay, so I'm going to do share screen. Okay, now can you see?
Mm. Yeah,
It's
Okay.
still the
but
order one. Same
still
Okay,
the
way.
can you
same.
see? Okay,
Yes, now it is moving, I
see the
think.
screen now? Okay.
Yeah.
Okay, so now I am going to do, okay, I'm going to do percentiles and quartiles and median and mode. Can you see this?
Yes,
Yes, we
ma'am. Now
can
it is.
see
And I am
the.
doing the heart rate. Okay.
Yeah, yeah. And now the value has come.
Okay,
We
great.
can see
Can you
that.
see all of this? So first I
Yeah.
selected the heart rate. Okay, and then I have done descriptive statistics on this.
Mm.
Right? Please try it out.
Yeah, yeah, I got it.
You can do coefficient of variance also. Right? You can do coefficient of variance variation also.
Mm.
You can do confidence interval of mean also. Right? If you click on the confidence interval for mean, right, you can see a 95 confidence interval for mean. Right? So all of this you can do. Right? Now if I
Mm.
click on the basic plots, okay,
Mm.
I can do something like an interval plot, because in this case it will be only interval. Okay, so it will give me an interval plot. Okay, or let me just look, let me just see, distribution plots is better. Okay, okay, this has given me a histogram. Can you see this?
Yes, ma'am.
You see this?
Yes, yes. Yeah.
Right, you can when you do a distribution plot, it will give me a histogram also.
Mm.
Okay, I can do something like a QQ plot, right, which is basically to see whether it is a normal distribution or not. Right, so it is on the line, so it's roughly a normal distribution.
Mm.
Right, you can do a pie chart. Right, it won't show me a pie chart because it has got a distribution plot. Okay, it doesn't work on that. Okay, and let me see if it has tables. Okay, let me see if it shows a frequency table. Okay, because it doesn't there is no possibility of doing this. Okay, so that is why it not showed me. Right, now let me just try.
Oh, ma'am. She's showing
Okay,
this.
let me just try doing a gender split. Okay, now what I've done is I've used gender and I want to see what is the difference between male and female. Okay, so now here it is giving me all the statistics that I want, now divided by female and male in terms of heart rate. Okay, and now let me see if it is gives me. And now it is giving me heart rate for distribution for heart rate for female and heart rate for male. Can you see this?
Mm.
Okay, so let me see if I can let me see if I take gender out here and I put gender here. Okay, and I put group out here. Okay, and let me see if I have a, now can you see this out here? Okay, so there was two groups out here between female and male. Okay, now it has given me the frequency tables as per gender. Okay, so I know that in the control group there were 200 female and 200 male. Similarly, in the runners group there were 200 female and there were 200 male. Right, and let me see if I can do something on a, I mean, I'll have to pretty much, some of it will make sense and some of it will not make sense, but yeah. Right, so yeah, let me see, it's heart rate. Okay, it won't take it. Okay, gender, heart rate. That's still not giving me tables. Okay, so this is basically, you know, you'll have to experiment with stuff, but this is basically how you do your and they said there is again, there is a lot of options which you can do. Okay, right, so a lot of stuff in terms of figuring out you will have to do. So I'm going to now take you to another file. Okay, I'm going to now open file. Okay, and I am going to sorry, so I'm going to open file and I will go to computer, final presentation here, and I am going to do something on ANOVA. Okay, right, so just open the ANOVA file. Okay, now what I'm going to do out here is a one-way ANOVA. As I told you, one-way ANOVA basically means that I have three particular groups. Okay, and then there will be one categorically, there will be categorical variables, there will be an independent variable which is going to be a categorical variable, and there will be a dependent variable which is a scale variable or a continuous variable. Okay, it has to be a ratio variable. Okay, which means you can do a mean of that, you can do a standard deviation of that. There can be some calculation that you do. So here, of course, they have called it as a scale variable, but we would know it better as a ratio variable. Okay, so in this last example, if you remember that we had done some treatment for headaches. Okay, and we had done it through Excel, but I am now demonstrating it through the JASP software, which will give you which will probably be, you know, more interesting to you. So I tried it out and I said, okay, this works also. So basically, if you look at this data set, okay, you have, these are the drugs that you have. Okay, and you had roughly, I think, 20 variables for cabazine, 20 for hedazine, 20 for parmoline, okay, and 20 for ibuprofen. Okay, and based on that, right, after taking the medication, okay, so people will realize that how much you would rate yourself on the headache level. Okay, so this was the value. Now when you are doing one way ANOVA, you will have to arrange your data in such a way that it resembles this. Okay, the way you arrange your data is also important. You know, in the earlier file that we were doing when in Excel, you know, I was arranging it into different columns, cabazine separate, adenosine separate, right? In this JASP, you will have to put your files in a way where the treatment variables are in one column and the corresponding pain scores are in another variable, in a column. Okay, so once you have this again, and of course if you want to change the column type, you can change it, but right now I'm good with it because it's very much showing me that this is a nominal variable. Okay, and this is very much showing me this is a scale variable. Okay, now I'll click on to ANOVA. Okay, so please click on to ANOVA, everybody. Have you all opened this file?
Yes, ma'am.
Okay, everybody can see the treatment and the pain score.
Mhm. Yeah.
Everybody's done it. Let me know when you have, I'll wait for another 2 minutes till everybody gets it. Okay, I'm going to click on ANOVA, and when I come to ANOVA, I'm just going to go to simple ANOVA. Okay, nothing else, just simple ANOVA. Okay, you will find a box like this. Everybody's got this box?
Yes, ma'am.
Okay, so what I'm going to do is, what is my dependent variable out here? It is pain score. Okay, so I will simply take pain score out here, and what is my fixed factor? I'm going to take it out here. Everybody's done that?
Yes, ma'am.
Okay, now first let me just look at descriptive statistics first. Okay, now when I click on this, when I say display, when I click on the descriptive statistics, okay, so one, of course, let me just, okay, so this is the descriptive statistics that I've got. Can you see that I had 4 drugs, each of them 20 of them? It has given me the mean. It has given me the mean. It has given me the standard deviation, and it has given me the standard error. Okay, and it has given me the coefficient of variation. Okay, now if I look at this ANOVA, okay, if I go to this model, sorry, okay, if I go to this model, okay, now this is my model. Okay, now you can see, okay, basically it says, the last time when we calculated and I showed you the slide, okay, I mean, I don't have to do any calculations. It is showing me that my F test, the value is 21.431. Okay, so basically what happens is, you always calculate your, it is in terms of your treatment and your between the sum of squares and within the sum of squares. Okay, so as long as the variance between the categories is more than the within the categories, your F test should be more, and then you compare it against the critical value. Okay, so here I can say that in terms of my treatment, that is between the groups, the variance was more as compared to the within the sum of squares. Okay, and that is why my F test is 21. F value is coming to 21.431, and I can see the p value is 0.0 less than 0.001, which means it is significant. Okay, can everybody see the p value? Now what it basically means, if my p value is coming as less than 0.05, it basically tells me that at least there is a significant difference between the means of at least 2 groups. Okay, now I have 3 groups. Okay, because I have 4 types of treatment, right? So there are 3 groups. So what it tells me in ANOVA, which says that I have, because it is positive, the p value is less than 0.05. What it is telling me that at least there is one group where the difference between the means is statistically significant. It doesn't tell me which one. Okay, now for that I will have to do something like a post hoc tests. Okay, now before that, no, there is something what you call, when you do an actually ANOVA, you do an assumption tests. Okay, now there is something called a homogeneity test, which basically checks for the variance. Okay, and there is a Levine test. Okay, now when you look at this, okay, test for equality of variance, okay, it's a Levine test. Now here you are seeing that there is the variance is, there seems to be a difference. I mean, it is significant. That means I can't possibly say that there is equality of variance is there between the treatment effect. So therefore I will have to do some corrections. So in this case, I'm doing a Welch correction. Okay, and this 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 actually adjusts for this, and then I will go on to post hoc tests. Okay, before that, let me do a descriptive plots. Okay, right, go to, there is something called a descriptive plot, just click on that. Okay, this is a descriptive plots, just click on that. Now what you can do is, you can, on the horizontal axis, you can click on this, right? So it basically tells me, right, and you have a bar out here. Can you see the arrow out here? I can actually extend this graph. I can increase the size, right? So it will show me that in terms of the treatment, you can see that ibuprofen is the lowest, hedazine is slightly, but pain score, if I have taken cabazine, it is the highest. That means it is not very effective. Okay, so you can actually compare the means using a descriptive plot. Okay, now post hoc tests, if I click on post hoc tests, okay, basically what I have to do, because I only have one way ANOVA, so it's only the treatment variable, I will take it out here. Okay, and these are standard tests that are there. Okay, so there are many tests that are there. Okay, for me, you know, a standard and a Tukey test is more than enough. Okay, can you see this? I can do at the most I can do a one for any also. Okay, the moment I click on this, it will give me a one for any test also. Now when I look at this table, everybody can look at this table? Can everybody look at this table? Post hoc
Yes, ma'am.
treatments, plan treatment. Okay, now you will notice that there is some areas which is dark. You just look at this. Sorry, spotlight. If I look at this, if I look at cabazine, right, you will notice that it's slightly gray. This one is also gray, right? Now you'll notice all this in this, right? In both the cases, this is, you've looked at the test and this is coming as significant. It is less than 0.001, right? This is less than 001, this is less than 001, right? So all these three, right? So what it is basically telling you, that the difference between hedazine and cabazine is significant. The difference between ibuprofen and cabazine is also significant, right? And the difference between cabazine and parmoline is also significant. Can you see this? Right? You can also compare it with your mean difference. You compare the mean difference and you compare it across the t value, the significant value. So for example, you see, right? If you look at this, you will find that there is the difference right? You can actually compare this. Okay. You can also do a confidence interval. Okay, if I click on confidence interval, can you see this? Now can you see the lower and the upper intervals? Right? So you can see in this, if you look at this figure, okay, now you can see this difference. It has 0 is there. Okay, it is included in the class interval. Even this, it's being included in the class interval, right? Okay, they've done up one for any, so it's not probably coming right now. But anyway, okay. So this case gives you the understanding that where the difference is there, and this gives you a, right, your descriptive plots will give you, will precisely tell you where the problem is. Right? As you can see that this one, by looking at this, you can look at, basically see that this is the least effective and this is the most effective, right? Okay, I'm going to stop share for the time being. Okay. How many of you did it?
I could do.
I know it looks a little Latin and Greek right now.
I could do it.
You couldn't do it.
Yeah, I did.
You did. Okay. How many of you did not do it? How do you feel, Sunil, after doing it?
Yeah, it's the only thing is it's very simple, but we should know how to do this. That's all.
Yeah, it is very simple as long as you understand the statistics and whatever it is, right? So, I mean, if you know statistics, I mean, doing it, software is always there to sort of help you. You have to always read out the background of the test. Who was not able to do it?
I think some of them may not have downloaded that.
Okay. So please download JASP. Okay. I can give you 5 minutes. Please download it. Please go ahead and download it. It just takes 5 minutes to download it. Go ahead and do it. Because we have another example to do it, and then we'll do on block designs. I want to, do a two-way ANOVA also. Just okay. So I'm going to go to JASP again. Okay, I'm going to share my screen. One sec. I'll just lock some of my files first. Can everybody see my file?
Yes, yes.
Can you see my screen?
Yes,
Okay.
Jasper.
Okay. So I'm going to open another file. Okay. I'm going to go to my computer. I'm doing another file. And this time I'm going to take something called a crop CSV. Okay. So this is the third file that you have. Okay. Now what I'm going to do is something called a two-way ANOVA. Okay. Now we did it in Excel that time. Okay. Now I'm doing it in JASP. Okay. Now if you look at this file, I have two factors in it. Okay. My dependent variable is the yield that I have of, in terms of whatever that I've used some crop, okay, some X crop, and I have basically tried to look at the yield of that particular crop. Okay. Now the two factors that I have is, one is that type of fertilizer that I have. So if you can, if I scroll when I look down, there are three kinds of fertilizers, right? Can you see the categories? 1, 2, and 3. Okay. So there are three types of fertilizers that I have. Okay. Right. And I can basically, put this as A, right? I can put this as A. I can put this as B. Okay. If I, and this one I can put it as C. Okay. Right. So if you see this, okay, it is now showing me as A, B, and C. Probably not done.
Ma'am, how did you do that, ma'am?
I just clicked on it. I clicked on the 3 and I did that. Okay. So I was able to do that. And then once I've done that, I've done that. Okay. And even for density also, I right now I put 1 and 2, right? So I can put a value out here. Let me see whether there is a value out here. Right. I can do low. I can do low. And let me say it is high. I just for the sake of I've done something. Okay. It needs to reflect something, but fine. Okay. So I can see in my data, you can see that it is reflecting in my data. Okay. Fine. Till now we are good. Okay. But make sure whenever you are doing this kind of a thing, okay, if I were to take an example, okay, if I were to do this kind of a thing, and let's say that the pain score of a patient depended on A, okay, the kind of treatment that person was being given, and number 2, it would depend on, let's say, whether it could be something like person could be male or female, okay, or it could be some age categories that I'm looking at. So I've basically looked at, one is in my treatment group in terms of the kind of treatment that I'm looking, and one is in terms of I am looking at something in terms of the age categories to see whether my pain resilience is, or pain scores are different across age categories and across the treatment that I have. Okay. So these are the two things that I have, right? So I can always, change, use another file and, compute those kind of statistics and, use this. Okay. Then I would go down to, I would click on ANOVA. Okay. And I am doing simple ANOVA. Okay. I am just clicking on ANOVA. Okay. Everybody's got up till here.
Yes, ma'am.
Okay. Now, what is my dependent variable? My dependent variable always has to be a scale variable. Okay. So I'm going to just click on this and I'm going to drag it to my dependent variable. Okay. Now, in this case, I have two fixed factors. I have fertilizer type and I have density. Can you see this? Has everybody done this? Please do it, everybody, please do it. Everybody has done this? Okay. Now, if you see on the right hand side on the results section, okay, I'm just going to annotate this, okay, and then I'm going to spotlight. Now, if I go to, okay, now if I go to fertilizer type, okay, I can see that the F value is 8.994. That means, and how many fertilizer types did I have? 3. Okay. And because I had 3 groups, my degrees of freedom is n minus 1, that is in this case k, and I have 2. Okay. And my p value, that means it is significant. That means there is a difference between in terms of the yield. The type of fertilizer that I'm using does cause a difference between the yields. So that is what it is telling me. Now, which fertilizer type, it doesn't tell me. It basically tells me that between the variables, between the fertilizer type, okay, there is definitely, it does cause a difference in the yield. Now, if second factor was density, now here also I can see that my F is coming as 15.178, okay, and the p value is, right, it is 0.00, which is also significant, right, which is basically telling me that even my density, right, that is also a significant variable. That means there is a difference between the yield between low density and high density. Okay. Now, if I'm looking at the interaction between fertilizer type and density, right? So, is there any interaction with that? If I use the combined factors of fertilizer type and density, okay, is there an interaction effect between them? Right? I can see that the interaction between the them is not significant. Okay. So, if I'm trying to, sort of devise something which is in terms of fertilizer type and density, it is not significant. Now, this is also important. If the fertilizer type and density interaction was significant, I may have wanted to do another, a type of another research design, which is called a randomized block design or something, because the interaction is significant. So I might want to kind of do something else on this. Okay. I might try to, vary my research design, but here I can see it is not significant. Okay. Now, I can go further down. Okay.
Ma'am, why did the degrees of freedom in fertilizer type and density was 2? Like
Okay. Density, there were 2 groups now, 1 and 2.
two
So that was
groups.
only 1.
Yes, ma'am. Then
Okay.
fertilizer type into density,
It
that
is,
one.
yeah. So this is also like k minus 1 and n minus 1. So if you multiply it, it will come as 2.
Okay, okay, ma'am.
Okay. Fine. Now, if I use if I click on descriptive statistics, okay. Now, what it does is, because I have 2 factors, it will give me A, high and low, high and low. Okay. So high and low, it is giving me 177. Right. Now it is showing me the descriptive statistics. Okay. Right now, homogeneity test, I'm looking at Levene's test. Okay. It shows that equality of variance not significant. I don't need any homogeneity corrections. Okay, so it doesn't, I don't require that, so I can proceed. Okay, let me just go on to descriptive plots. Okay, now let me look at density as horizontal. Okay, and let me look at fertilizer line as separate lines. Okay, now there isn't much difference out here. Okay, I will just try and do this. Okay, it doesn't show difference, too much of difference, it's all within a particular range. Okay, but it definitely shows that, you know, between A, B, and C, right? You can see it, though it is the situation is consistent, but it does show that between the fertilizer type, between low and high density, there is a some sort of a difference. Okay, that is at best you can see, right? You can even vary this and put fertilizer type in the horizontal axis and density out here. Okay, so you can even try that. You can try this. Right, so it will give you a plot to better understand your data. Okay, so now you've given a fertilizer type. Okay, this is A, B, and C. Right, so you can see yield is different here, yield is different here, yield is different here. Okay, but between the low and high density doesn't seem to be much of a difference. Okay, so this is what it is showing. Now let's go on to the post hoc tests. Okay, now basically I want to see, when I see post hoc test, I want to see whether, you know, which are the fertilizers and the density, which is the difference. Okay, so I am just going to see, this was non-significant, so it doesn't make any sense for me to do it. Okay, I'm only going to look at fertilizer type and density. I'm going to click on both. Okay, and just wait for a second. Now you can see, in terms of fertilizer type, right, you can see the difference between A and C is significant, right? 0.001. This is also significant, but much lesser. Okay, but this is definitely significant between A and C. Okay, you can see that it is different, and of course you can compare in terms of descriptive statistics A and C. Okay, you can definitely compare that. Okay, mean of, you can take an average of this and you will compare that between A and C, there is a difference. Okay, so that is where it is showing, right? If I look at density, okay, it is also significant between low and high. Okay, so the mean difference is 0.462. Okay, so if I look at, if I between density, if I take the total of high and take the total of low, I can do that also. Okay, so if I go to descriptives, okay, let's say I want to descriptives and I want to do density. Okay, and I want to do, okay, so it is giving me the density. Okay, and if I want to do density, one second, if I want to split by density and I want to do fertilizer, I want to do yield type. Okay, so it's giving me, can you see the difference? Right, so I can do this, I can do that in terms of yield and density, or I can also, if I want to figure out, I can do in terms of fertilizer type also. Okay, so I know the means of A, B, and C, and I can see the difference between the all of them also. Right, so I'm going back to ANOVA out here. And let me see. There is something called marginal means also. Okay, let me just see what this is. Okay, if I go to marginal means, I can do this also. Okay, and I can do marginal from. Okay, so if I look at marginal means, okay, it gives me A, B, and C, the means out here, and for density also it gives me the means out here, and it gives me the confidence intervals also. So I can do that through the marginal means also. Instead of going to the descriptive types, I can do it for this, and it will give me a 95% confidence interval also. Got it, everybody? Okay. So I'm going to stop my file here. Okay. How does everybody feel right now? Good, bad? How does everybody feel? Are you feeling good?
Very good.
Very good.
Relax.
Huh? We've put a tool in your hands. आपको सबको शस्त्र दिया है. I've given you a weapon. Yeah, of course, it will take time to understand, right? I spent from morning to evening, I was trying to do JASP only because I hadn't used this. I'm more used to Stata, so I said, okay, let me learn a new software. Okay. Anybody game for another 10 minutes? Want to do another thing, or shall we stop? I can just walk you through randomized block design. It will take me 15 minutes, 15-20 minutes to do it. You want me to do it? Yes, it is very easy. It looks very easy. Right? And the best part of it, you can copy your code and put it in your file. Right? Whatever analysis that you can do, whatever stuff you can do, you can just copy it. Right? If I just, you click on the right thing, you just copy it and copy to the blender, and you just go and copy and paste it. That's the best part. You open a Word file and just copy it. It will copy the table. Right? I'll just show you once again. Right? So for example, I go to JASP. Okay, I wanted to copy this. Right? So I just go to click on this, copy, go to a Word file, easy. Right? And I may want to do a little bit editing, I can do it later, but yeah, I mean, my table is done. Right? I can just I can change the font, I can whatever do, I can do whatever I want with it. Right? It's a APA type of a stuff. Right? So shall I have 10 more minutes? Yeah. Shripriya, what do we do at KM? Do I carry on a little bit, or shall I revert to next class?
I mean, anything is okay for me. Like Sunil sir's discretion.
It depends on the class, because randomized block design will take a little bit of 15 minutes, 15-20 minutes.
I hand over the ball to Sunil sir.
Really, we can do it in next class. I think
Okay.
some of them may not have downloaded the JAS.
Okay.
So they may not.
So tomorrow, please download Jazz. Please try out these files. Okay. Please experiment. Okay. And next time we'll do randomized block time. Then we'll do repeated measures, ANOVA, and we'll also do linear regression. And all of it on JASP. Right, all of it on JASP. Right now the idea is that you should be able to do things on your own. Right, and then we have only multiple regression and logistic regression also, which you can do on JASP. All of it you can do on JASP now. And nobody needs to learn any software or any coding or anything of that sort. You can just click and stuff and be happy.
Okay.
Okay, great. Okay, good night then. Yeah, Sunil. But I really wish somebody would say something. Everybody is very quiet.
Today, at least Dr. Shravani was very interactive. I could see. She even asked queries.
Okay. That's nice. Dr. Shravani, where are you based?
I'm from Vizag.
You're from Vizag. Okay. It'll be fun to work on your research projects with you guys.
Yes, ma'am.
I'm looking forward to this.
Yes, ma'am. Thank you.
Okay. Chalo, have good fun. Good night, everybody. Right? Till we meet next time. Please download Jazz, please.
Hey, good night.
Okay, good night. Okay.
Thank you, Dr. Vinti. See you in the next session. Thank you, everyone. So maybe I will put a reminder also on Friday to download Jasper and just get a hands-on before we join the session on Saturday. So thank you, everyone, for joining. See you in the next session. Till then, everyone, take care. Bye-bye.
Bye.